Hey everyone, welcome back. Today we are going to be looking at the discriminant of a quadratic and how this affects the graph of those specific quadratics, alright? So we're going to be, if you're playing along at home with the Hazy textbook, this is chapter 2D.4, alright? What I want you to do is take a quick moment and just graph these three quadratics in pink text. Take a moment, pause the video, just have a look at how the graph interacts with the x-axis. Does it cut the axis twice? Does it touch the x-axis? Does it completely miss the x-axis? All right, I'll give you a quick moment just to have a bit of a play around with that. So please do that, pause the video, have a bit of a look. All right. Hopefully you guys have had a look at those on the graph. So we're going to actually look at how the discriminant affects that. So hopefully you guys noticed in this first one that it does in fact cut the x-axis twice. So remember, if we're looking at the discriminant, our discriminant formula is delta equals b squared take 4ac. So remember, the coefficient for our x squared term is a, our coefficient for our x term is b, and our constant coefficient is c. So we're just going to substitute those values straight into our formula. All right, so the coefficient of x is -3. We throw that straight into our b in our formula. A is 1 and c is -2. Once we simplify that, you can throw it straight into your calculator if you like. So that comes out to be 17, which hopefully you all agree is greater than 0. So when we have a discriminant that is greater than 0, our quadratic will cut the x-axis twice. All right, so that is the main preface of this exercise. If delta, the discriminant, is greater than 0, it will cut the x-axis twice. This second one, hopefully you noticed that it touched the x-axis. All right. So if we're looking again at the discriminant, we find that our discriminant in this case is actually equal to 0. So if our discriminant is equal to 0, then we can say that the graph will touch the x-axis. All right. So if the discriminant is greater than 0, it cuts the x-axis twice. If the discriminant is equal to 0, then it will just touch the x-axis. And then hopefully on this last one, I think you guys know where this is heading, all right? You should have noticed that the graph, the function actually doesn't touch the x-axis. So when we find the discriminant of this quadratic with our really bad negative sign in there, all right, you'll find that the discriminant is less than 0. -47 is a negative number, less than 0. And in this case, if the discriminant is less than 0, it does not cut the x-axis at all. It does not touch. All right, so there are three conditions for our discriminant to sort of determine some information about our quadratic graph. All right, so just to rehash, if the discriminant is greater than 0, it will cut the x-axis twice. If the discriminant is equal to 0, it will touch the x-axis once. So it will be touching either at its minimum or its maximum vertex. Then if the discriminant is less than 0, it does not cut the x-axis, all right? We're going to move on quickly to positive and negative definite because it does actually involve this discriminant conditions, all right? So positive definite quadratics are quadratics which are positive for all values of x. So what this means is ax squared plus bx plus c, our general quadratic, is greater than 0 for all, so this little symbol is for all x in the real number set, okay? And our graph will look something along these lines here, very badly drawn, but our whole quadratic will be above the x-axis. So for a quadratic to be positive definite, we need two conditions to be upheld. We need a to be greater than 0, which means we'll have a concave up-shaped quadratic. And we need our discriminant to be less than 0. We just showed above that if the discriminant is less than 0, then our quadratic will not touch the x-axis. So we need a greater than 0 and the discriminant less than 0. For negative definite quadratics, they are quadratics which are negative for all x values, okay? So similar thing, so a general quadratic ax squared plus bx plus c is less than 0 for all x in the real number set. And our graph will look something along these lines. We'll have a concave down all below the x-axis, all right? So a quadratic is negative definite if, so same conditions as above, but our a will be less than 0, okay? So we need that concave down shaped quadratic, and our discriminant is still less than 0, okay? So there are those two conditions there, so negative definite, a less than 0, discriminant less than 0, positive definite, a greater than 0, discriminant less than 0, okay? If you want to have a crack at the following questions, so in the Hazy textbook, 2D.4 and the following questions there. All right, we'll see you guys next time.